So today I have two problems planned. One of which is I guess like a two-stage, fairly easy warm-up problem, and then the other one is another problem that I got as a real interview question, and I think
Yeah.
is a fairly interesting dynamic programming problem. Um, and yeah, I guess we'll move forward with those two.
Yeah.
So the problem here is I want you, given an array of values, find the two factors that lead to the largest value. So, uh, and we'll just return we'll just return um, the product, get largest product.
Right.
And this time I'm not going to give you any sample data or anything else like
All
that.
right.
I'm going to be more hands off on this one.
Sure. All right. So we're getting the largest project between two arrays. So like if I did you know get largest product of just like 1, 2, 3, um, then that would return 6 basically.
Uh, yes, exactly.
Okay. And then I suppose the relevant questions would be, is the array sorted?
The array is not. You can't make any guarantees about the orders of
Yeah.
values.
So not necessarily sorted. And then presumably the numbers can be negative as well.
Yes, exactly.
Yeah. And then, all right. So then, and I also assume largest project with like a negative value. If you have something that's massively negative, then it's not absolute value. It's just whatever is the most positive number.
Yep,
All right.
exactly.
Okay. So then, um, I mean, the largest project is just the largest two values. Um, so I suppose we could sort the array, but also there's really no point in that. I think that that's going to be a lot of overhead, and we don't really care about the sorted value anyway. So we can, since we can't make any assumptions about the order that they're in, really we can just do a very simple O of n like loop through. So we would say um, first max, or well, that'll have to be infinitely negative. Which I think Python has an infinity operator. Do you mind if I look that up, or should I?
Go ahead. Yeah.
All right, Python infinity. I just think it's really convenient if so. Um, oh yeah, so only in Python 3. So then I guess we can either choose just an arbitrarily low number, or we can say we can start it out as none. Um, uh, and then let's see. I suppose we'll just loop through. So for num in nums, and then compare. Well, so we could do a try and accept. I don't really like those being nuns, but I guess that's the best representation without a minus infinity in Python 2. So in that case, yeah, I suppose it's better than having a limit on how large or necessary. Well, it's better than necessitating the range of these things. So okay. Although in fact, let me just bust open. Can I use this as like an interpreter over here? Can I do like
Maybe I haven't tried that.
-5 greater than none?
There you go.
All right. So sweet. Okay. So if num is greater than first max, and then, so how do we handle having them both? And I've got to keep one smallest. So basically the cases are that it's bigger than, we'll say first max is the biggest value. So then we'll say, okay, if number is greater than first max, we'll just shift. So second max is equal to first max, and then first max equals num. And then I think that should implicitly take care of it, because second max will just continuously be shuffled down to the second highest maximum, and then we can just say return first max times second max. There we go. I think that should work. Or, well, actually, we should say greater than or equal, because if there are two instances of the largest value in an array, then first and second should both be instantiated to that. So let's run that. Oh wait, I need to come up with test cases. So to get largest, well, I could just copy this. So we'll test it out with things that are negative, I suppose. Do like negative 10, negative 20. Or actually, let's do that the reverse order to see if it updates that way correctly. Just test those out. Oh, I need to do. Okay, 6 and 0. Those are definitely right. Let's see if can I guarantee that there are going to be numbers in the array?
Yeah, they're definitely going to be numbers. We'll, I guess, even make it more constrained. They'll be integers.
Okay, and at least 2?
Yeah, there will be at least 2 values. Is that the right value in your second test case there?
Oh no, yeah, that's right. Wow, I didn't catch that, because obviously negative 10 times negative 20 is much larger. So really, the thing is that they've got to be. Wow, I can't believe that I glossed over that entirely. That's yikes. I hope I don't do that in an interview. Okay, so That's tough, because then, of course, I need to basically have 2 possibilities, because if there's a massively negative number, then it needs to be either the 2 largest negative numbers or the 2 largest positive numbers. So, but then, of course, if they're both negative, they're both positive. Okay, so, in this case, it almost would make sense to sort it, but that's a lot of code, just so that I could very easily test the first 2 most negative and the first 2 most positive. I mean, what I'm thinking of now, the only one I'm thinking of, is to keep track of 4 different numbers, which seems very awkward. Keep track of the most negative, the most positive, and then compare the 2 at the end. But like we were talking about going for the best solution at the last interview, and that doesn't really seem like the best. So maybe I'll keep track of the largest product instead, I suppose, but that again doesn't necessarily work. Well, so, I mean, no matter what, keeping track of the most negative and the most positive is better than just testing every number compared to every other. So then, yeah, I guess that's the way that that's the best way that I can think of to do it right now. And there's nothing really for that. So, yeah, first min, second min. Definitely worried about this versus the, actual best answer, but at least it's quick to implement. Okay. So then we'll just return the max of those two. Yeah. Okay. Oh, and then, wait, why is that happening? So clearly that's got to be the mins. So if number is less than or equal to first min, second min, I suppose I might need to go in the opposite direction with that. So yeah, it depends really on which order they're in, because the way I've got it ordered now, I get the minimum number. Yeah, so then really what I need to do is, if the number is less than or equal to the second minimum, then first min becomes the, yeah, then, oh man. This is really puzzling. I'm not sure if I'm just not as much on it today as I was before, but hmm. So, okay, what I can do is basically I encounter that 20, and that's going to, well, oh no, my problem here, I think I'm being dumb. My problem here is that something like a -5 is going to, never going to compare less than none. So basically, I'm faced with the other end of my infinity operator. But then the only case where these actually matter is 0, because of course, you know, the minimums are only going to feasibly be larger than the max, or either of the maxes multiplied if they're both negative. So then, just as a sanity check for that second code, or I guess I might as well just test it quickly. That'll tell me immediately. 6 and 0. So, Man. So then I'm encountering the problem I first thought that I was encountering, where basically I encounter a negative and then I encounter another negative. And in fact, this might occur actually with an array that's sorted inversely with my first comparison. So really, I need to say if number in both of these cases, if the number is greater than or less than the second, then we test if number is, you know, that same comparison to the first. Then we have a different case. So in that case, then the second max needs to become the first max. And then the first max needs to become the number. Otherwise, second max. Or oh wait, okay. Yeah. So that way we just shuffle it through. Not the most elegant solution, but okay. That's finally better.
Cool.
So, yeah. All right.
So that works. And let's not write the code for this just yet. But well, we'll not write the code for this today. Uh,
Mhm.
can you talk about how you would extend this to work with three factors to get the largest product of three
Right.
factors?
Well, so I could continue just adding, first, second, whatever mins. That doesn't seem like the right approach. So I could feasibly come up with, or I could just use a queue, and basically, each time, there's a minimum or maximum value, that's greater than the first, I could just basically push numbers onto the queue and then, have them go up. In fact, that's probably the best general approach to basically, so you make a queue with a certain, what would you call it? Necessary length. I forget what you call it in like tuples order or something. And so then to ensure it's like O of n, or in this case O of 2n comparisons, I guess you well, no, because it could be in a sorted case. It would be sorry, my thoughts are a jumble. So actually, I was thinking that in sort of an adversely sorted array, you would have to compare it, to every other value just to shuffle it up through the queue. But in each iteration, the queues are going to be a maximum length of three, or of n numbers. So basically, for each number in the array, you would push it onto two queues, one keeping track of the minimum numbers, one keeping track of the maximum numbers, and then that would just shuffle through each. So say that you have, queues of size n and then array of size k. Then I think it would be for each value of k, times 2 times n, because you have n comparisons for each value k. Yeah. And then,
So
you know,
is with if you're using a data structure like a queue,
yeah.
can you guarantee that you're going to get the in smallest or in largest values? Is that the right data structure to use for that?
So I'm thinking maybe Q isn't the right word for what I'm thinking. It would be something that you would basically, um, so each iteration you would push it up through this structure, and then whenever it reached the max, so say most numbers wouldn't compare against in the max queue, most numbers wouldn't be greater than the very first entry in that queue or in that structure. Then it
So
would be placed in its maximum spot within that structure, and then you would pop off of the end.
right.
Um,
So there's some ordering in that list that you're building
yeah,
in that collection that you're building up.
yeah.
Okay. So I guess given the read and write loads to that kind of collection, like what do you think would be a good good structure to use for that? A good
Um,
yeah.
honestly, um, honestly, a linked list would work pretty well. It's kind of an unusual structure, I think, for most purposes. But if it's only length n, I guess that you wouldn't necessarily want to traverse the entire thing. But actually, no, because so in every case, you're keeping essentially the smallest maximum or the largest minimum at the very head of the linked list. So then, in each case, you can sort of bubble the number up, which has comparisons to bubble sort, which is great. But in this case, it's actually essentially fine in the runtime. And then you just switch the head from the first element of the list to the second element of the
Right.
list.
So linked list, I guess that's easy if you're adding a new value that's the smallest or largest value. But if you're
Hmm.
adding something that's kind of in the middle, um,
Yeah, then you have to traverse the entire thing.
yeah.
So the reason I was thinking that's not necessarily a huge problem is that you have to compare to every element of the structure that you're inserting it into anyway to find the proper place within that structure. So basically, you're just shifting it from, one comparison to two. You have to not only make the comparison, but then just read the next variable of each node. Um, so I was sort of figuring, just going on orders, like you're already, say, making n traversals of the linked list length n, or a maximum of n,
Right.
worst case scenario of n.
So you
So
said.
then,
Okay, go ahead.
just that it's a coefficient instead of an extra order of, complexity.
Okay. So you said you'd have to check on the order of n elements to figure out where a value would sit inside of a linked list.
Hmm.
So that's, I guess, true of basic linked lists. There are some more fancy data structures that you can use.
You could have a
Variations
tree.
of a linked list, or exactly a tree, which I think is probably the ideal data structure here.
Yeah.
I guess I'll throw this in there before we get to the next problem, because it's not so much feedback; it's something that an interviewer would say. There's a more complex linked lists that you could have.
Hmm.
You could have you probably, I don't know if you need you might need I guess link like a linked list that goes in both directions. I
Right.
can't think of the term on top of my head, but there's also, I think it's like a skip or a span linked list, where
Oh
basically
yeah.
each node points to the next one, and then to the second node from that, and then the fourth, and then the eighth. So you can kind of do like a
Right.
you
Yeah,
have
I've heard of those being used for hash maps actually.
for hash maps. Oh, like
Yeah,
with
just like
collisions or
yeah, collision handling.
okay. Hmm.
Yeah.
Um. All
All
right.
right.
So, moving onwards. I'm gonna.
Yeah.
Hopefully, I can comment all of this.
Uh-huh.
Nope.
Yeah.
uh, all right. I'll just copy this in my um, editor that I have going
All
on
right.
here. I'm taking
And then
notes and
just
I'm leaving them on the screen for the viewers to see my silent note taking as we
right.
as we develop. Um, okay, so this problem is a lot more beefy. There's
Hmm.
I think definitely a lot more moving parts. Um,
Hmm.
and my strategy here, I'm going to be more hands-on in the sense that like you can ask me questions and I might
Hmm.
kind of point you in the right direction if we start going kind of the wrong way. Uh, but I'm not going to give like that much, I guess, kind of data for you to have as like your. I'm gonna let you kind of come up with your data and everything
All right.
for this problem.
Sounds good.
So, without further ado, I want to write a function that will let me know if a username has a bad word in it. So
Uh-huh.
we'll have like def has bad word name turn. We'll we'll say everything's bad for now, but right. So if you have something that is like hello is a bad word.
Yeah.
Then a username like hello there is bad.
Uh-huh.
So yeah, if it has that in the string, but
Right.
the complexity here is that I can represent certain characters, and this will be a mapping that is defined before runtime. This isn't like a dynamic thing,
Mhm.
but I can write this in kind of like the leet speak,
Right.
where this is detected as a bad word.
Yeah.
Cannot type today.
Sure.
So that's the
Okay.
problem.
What's that?
So that's the problem.
Yeah. Okay. So considering my choice of data structure sort of failed last time, I'm actually thinking this is a good application for sort of an interesting one. Like I don't know how you pronounce it, like a trie,
It's pronounced tree. Yeah,
just tree. Yeah.
that is a great
Um,
place to start.
Nice. So that's probably what I would do. um, and then I guess I would need to make a class for that. So I think in Python that's just class try of object. And then we would want so we would want something like I suppose that really when we're instantiating this, we just need the space for everything. We don't need to start it out with anything. And I could come up with fancier ways to do the init function if I needed to. So then what are we going to need here? We're going to need basically, so actually what I want is a try node. So then we'll have, well, so I've never actually made one of these in Python, so let me just think about the implementation a little bit first, if that's all right.
Sure.
So each try node will obviously contain a character, and then it'll contain all of the next characters. But then we need ways of looking that up, which I suppose could just be a list of try nodes. And in fact, it has to be directional, I think, because you can't just look up the general L, right, and hello, because that'll lead to so many different things. You could get basically like defining a grammar, crazy things. So I guess you actually need try node. You need a character. So self.char equals equals char, and then you need a next. Oh, and that's a keyword in Python. So let's do next node, and then that also sort of implicitly, gives what the next node is. So then I suppose that we'll have just a class try object to come up with like an initial, basically it'll just store an initial list. So then we can just do def init, and then we'll have first node, or first nodes, and then something like self.roots is equal to, it was just it'll be a set of the characters of the first node. So I guess, oh man, yeah, there's definitely a lot of complexity here. I would need to actually make a set of these. I think they would need to be hashable, and I don't really know how to do that in Python. So then I guess what we'll do really, I'll just make that a dictionary of, so then basically for node and first nodes, we need node.char to node, a dictionary there. So then I can, just so that, the usage will be something like, so actually this is a good place to start this out. So, so name is the bad word. So then I can say tree equals tree, and then we can just say equals none, and I think that won't fail on this. Well, maybe it will. Well, so essentially this, I suppose, would have been, this will be an instance of an object that's, sort of stored elsewhere. So I can, is it all right to assume that I have a tree, or should I build that out?
I guess you mean a tree of the structure that you'd expect to detect these bad words?
Yeah, so I'm assuming that basically the tree is just my representation of the bad words that I know, right?
Right. Yeah, and so that data structure is pretty important, and building that out is non-trivial too, so that's definitely part of the problem.
Okay. So then, so should I just, all right. So how should I really build that out in terms of, so I've got this function here has that word, whoops, and there's really no good spot in there, right, to build it out because this function, I mean, it sort of explains itself. So should I define another function to explain how that tree would be built out?
Yeah, you could just have def pre-compute.
Okay,
However,
sure.
however you want to do it.
Yeah, all right. So then we'll just say like bad words. That can just be a list of bad words. And then, well, so I'll also need a translation to characters. So that can actually, So this is interesting because the try node will have to have all representations of that character. So I guess I'll sort of handle that as it sort of, comes to be. I guess what I need here really is a dictionary or some representation of every representation of a character. So we can do char reps. So then for each word in bad words, whoops. In bad words, we need each character of that. So chars equals, we'll just make a list out of word. And then we'll make either make a new node or add it to the tree. So we can say, so really what I need here is, I think that it doesn't make sense in this case to have an instantiation there. Maybe we can figure out how to do that later. Anyway, for now, this can just be a dictionary. And then we can say def add, we need a char. Although, so traversing this is an interesting problem. So really, actually, I should have def add, and then a whole word is probably the way to add that to make sure that it adds in the correct way. So then, yeah, add, and then this makes sense as a dictionary, and then I can use get methods. So maybe next node should also be a dictionary, or I mean, it should be a dictionary. I don't necessarily know the context I'm going to want that, so I'll say should be a dictionary to all next. And then really, I want the translations within this tree. So I can pass that in. So then, I guess we'll do add word try equals try, and then we do need this here, and then char reps, and then for the init here, we'll do char reps. And then for the purpose of adding, the tree will have that for, determining basically everything that could follow. Okay, so we'll do that. Then for each word in bad words, we've got the characters. I don't think that we need that. We can just say bad word try dot add of word, and then I suppose return bad word try a tree. I keep saying try. Okay, yeah. So then in this add method, basically, it'll get that word, and we'll want to say this is where we want to get the list. Characters equals list of word. Okay, and then basically, we'll say, I I suppose so. We want some sort of insert. So we want to sort of recursively descend down those nodes. So then we can say something like, so basically we need, so the first issue at hand is whether that first character is in charets, or I mean is in roots. So we need to do self.roots of char 0, char 0, equals self.roots.get that first character, and then if it's not there, we can return a node with char 0, and then we don't have the next node yet, so that's a problem for my constructor there. But also I think it's pretty standard anyway that this can just be, it'll have to bottom out at some point, so then we can do it like that. And then, all right. So let's see. And then
I really like the direction you're going with this. I want to make sure one thing's being considered. So remember that like an L can be represented, or I'll do O, can be represented as
0 or something.
No, or 0, exactly. So like this kind of to have this complexity where I'm wondering, if do you want this complexity in your tria? In your you got me thinking right now. Do you want to have all of the possible representations of a bad word in the in the tree, or do you want just the I guess the plain English representation in the tree? And what are the implications of having that, and how you get your answer?
Yeah, so I was thinking about that, and I guess I should have been thinking about more of where to place this. It would be easy, but not very space efficient. And I think in this case, like, there are so many possible bad words in any, situation in which you would be considering this kind of algorithm.
Yeah.
That you would want something fairly space efficient. So really, it should be a level of basically when you're looking through the tree, you visit each node, you tell it which character you've got, and then that node will translate that character to basically some base character. So every 0 is also considered as an O, and then for every representation of that character, it checks. So basically, say with hello, you would just have hello represented in the tree.
Okay.
And then when you are computing whether someone has a bad word, for each character there, you say, okay, we've gotten this character, say an H, and then you say the next letter in this string that we're checking is an E, or is a 3, I mean. And then I suppose that's where you need it. So you say, all right, so check for the node that has an E, or for the node that has an H, what is the next character, and then that's when you compute the 3, can also be interpreted as an E.
All right. So I want to, I guess, add another constraint. So we want to optimize for runtime and not memory consumption. So I would switch that around. I would put more of the complexity into the pre-computed tree.
Right. Okay. So then what we should do is when we're building out the tree, put every representation of that next character into the list of its next nodes.
Yeah.
Yeah. Okay. So so then maybe what would be good is to here have something like def add next next char, and then so then or maybe this needs to be up in the tree because each add is when that gets interpreted. So it would make sense to have an add next. So man, I'm just struggling with the I guess that the tree is what should work with all of these nodes, and then the node can really just be essentially storage. And then I guess just for like Java style class safety, we can say set next self next nodes. And then, yeah, this does need to be the next nodes. Next nodes equals. Doesn't really matter, but just for the, safety. And then actually we can have this be, like that, so that nobody else can read it. Def get next. Self, return self next nodes. Nope. And that's just style, I guess. So anyway, then in add up here, so basically I guess it makes sense to do the underlying control flow. So for each, add word. Maybe we'll change this to add word because there will probably be some sort of add next. Just sort of to split that conceptually. So then, I guess really what I need is, so this is what I need. Every underlying representation, this is also going to be a dictionary. So that I can just, for the sake of having a very universal function, I basically always know where I stand, what structure I'm looking at. So then, so for add word, I need some sort of like def add next maybe. Where basically I'll say really I just want so I want to get the root and then add to that. So self.roots, so I want to ensure that it does have the root. So either it doesn't, so okay, I've set it correctly there. And then now that I've ensured it has that root, I can say I can basically start moving forward. I can do self.add next. Current node next char. Self.roots char 0. Or I can really do next chars. And then chars starting from 1. So that I'm, excluding that character. So then, although here is also where I need to keep track of that potential translation. So really I need to do for rep in self.char reps of char 0. And then each of these should be representation. Okay. And then, so that's tough because then I need to recurse for every single root representation of that character. Mm-hmm. Definitely a lot of moving parts in this problem.
Yeah. Sure.
Okay. So maybe it just makes sense to, hold or do some method, like basically factor out some functionality of this. Let me take a step back real quick. I suppose it might be sort of enlightening for where I want to go to look at the flow in has bad word.
Also, since you're kind of taking a step back, I think one of the things you might want to do, I think you should do now is define how you want to declare the mapping of what characters can represent, or how a character can be represented by other characters.
Right.
I don't think I've seen that anywhere.
Yeah. I guess I haven't.
Maybe start with.
What I was thinking. Oh yeah. Well, so what I was thinking was just generally like a mapping of So initially I was thinking something like, O can be all of these different ones,
All right. That,
below, but also that doesn't really work because you really need a reverse lookup.
okay.
Right.
You can define it that way. That sounds fine to me. Yeah.
To say, yeah, like O is mapped to 0, say. I mean 0 is mapped to O. And then you would have several entries like that. Just since we're not caring so much about space, but more about speed. So then, yeah. So assuming we have that, and I guess that's another thing because I needed to build out the tree. So am I assuming that that representation is passed in, or am I also writing like infrastructure to build out this dictionary?
Well, we're not building out the dictionary. That's like a kind of a just hard coded
Unassuming.
mapping.
Yeah.
I guess it's not really assumed because I want you to build something out that'll
Right.
be meaningful for the test cases that we'll build. But yeah,
Right.
you're responsible for making that too.
Yeah, okay. For just laying out what it's meant to, and I guess if I'm building the test cases, then yeah. So okay. Um, so I'm assuming that that's my underlying representation. And then um, okay. So so every time I'm adding a character um, to the tree, yeah, that was what I was faced with next. Was basically, hmm, hmm. So I can't help but feeling like there's some better way to factor out, some element of computation here. So let me just think about this from like a mile overview. I guess in each step, what I want to do is um, look at each. Yeah, so I think I've actually I've made maybe some poor choice of data structures here because at each step I want to look at each node and then build out the next, but that requires keeping track of these really massively divergent trees,
Hmm.
um, where I've got H to, or really it's more like L to O to capital O to 0, which is mostly just it's really kind of difficult to build out that way. And since these dictionaries are hashable, it's really easier, I think, to just keep track of each representation. If I'm doing a reverse lookup here, then it's really not a substantial space increase to just build out O and then translate these like at whenever you're looking at the characters during lookup, because that's just assuming the hash map works well, then it's an O of 1 lookup each time. So then I really can keep track of this the way I was originally thinking of just HELLO is a bad word, and then when I'm reading through each character, I translate before looking up that character. Um, so then what I need to do instead is chars is self.charreps of char for char and chars. So then I should, no matter how it's represented, I should get HELLO instead of H3110. And that I think is just easier to handle. So so self.roots of char 0. Oh yeah, both of these can now be char 0. And then get that, or else create a new node, and then I can do self.add next, char 0, chars 1. Okay, and then add next. So I've got current node because I've done the lookup here, and then I've got every character that comes next. So then I can just say curnode dot set next to try node, and so then this doesn't need to be a dictionary. Or well, actually, oh man, I guess it could be. Oh yeah, that was my using with a set. So currently I've got it as a dictionary. So there could be presumably multiple things that could follow from the next node. So in that case, I definitely need something big, but not necessarily hashable. I'll just look up. Maybe there's a very easy way in Python, so I'll look up Python hashable because I really think a set would be the best structure to use there if I easily could. Because I'm assuming that there's just some function like Python likes to have these like dot underscore repr or hash maybe. So maybe Python make object hashable. So, so it's like
I think
yeah.
I think it makes a lot of sense. You definitely don't want it to be a single record there, so you want some kind of collection. Otherwise, you're really just building a linked list.
Well, and it's true, yeah, and it's true that I guess I'm being kind of dumb here because if I make the dictionary is already a hashable type, and if I make it a dictionary from a character to the node representing that character, that's just sort of automatic built-in hashing.
Yep.
So I guess yeah, I'll keep it as a dictionary, and then I'll just make sure that it's clear that it's a dictionary from character to that node's. Or to the corresponding node.
Yeah.
Okay. So then set next should be or I'll do add next. So then
I see.
And then I guess I'll have to do a git here. And then if there's nothing there, then I'll make another try node. Or, well, no, it should actually be... oh, wait a minute. Yeah, so a try node of just next char. Or wait a minute. So, okay, and then if it's... oh, no. So, okay. So then of the next node, so next nodes is a dictionary from characters to nodes. So either there are already characters in next nodes, in which case, yeah. So or there's nothing. So I guess. Oh, okay. So what I'm doing here is really I need list. Right.
I wouldn't make it a list. No.
No, not list because yeah. So okay. I'm forgetting a lot of things. So either that character is already in the dictionary, and then I just need to, and then it doesn't really matter because we'll go to that next character, I believe. Or I need to create it. So yeah. So I think that this is basically it. We'll see how that plays out. Okay, so set next. So then set next should be next char is 0, and then wait a minute. So I'm okay. So I'm trying to do the computation in two places here, so it probably makes more sense to make it a tree node within the tree node structure. So I can just do set next to xchars 0, and then I also am forgetting to do self.care reps of that. And then okay, so these are all bad. Okay, anyway, I was just thinking if there was going to be a collision, if that might not, actually be in there. So, which
Okay.
actually,
So then this set next this next char is going to be an array, right? Instead, because you're looking up the first character of the word that you're building,
Mhm.
and then you're looking that up in your character representation mapping.
Yeah.
Oh, well, actually, no, you didn't define it
It's,
that way.
it's no, yeah, because yeah, the mapping is defined the reverse way. Yeah.
Right, but it's still the case that one character can mean multiple things.
Uh-huh.
It's kind of I guess, like a many to many mapping.
Right.
And you did reverse that, but it's still,
Still going to be an issue.
yeah, it's still like a many to many, I guess.
So
Because L can be represented as like a one, like a capital I or an L, and the same thing for an I can be represented as a L or an I. So.
oh yeah, as either. Well, so what I was thinking is to basically standardize. So in each case, it's going to be sort of many to one because I'll have like basically I'm saying every zero, every capital O is a lowercase o. And that's how I would build out my character representations dictionary.
Okay, but so if you want it to be you said like a one-to-one mapping, like every L can't be a capital I because sometimes it's actually going to be an L.
Uh-huh.
So I'm saying it's not like a one-to-one
Right.
mapping.
Right. Oh yeah. Yeah.
So your previous instinct of having a character that can be represented as, an array, and you did have a good idea of flipping that, but it's still going to be like a one-to-many
Yeah.
relationship.
Yeah, I see what you're saying.
And then that'll of course make the recursion for building the tree a little more complex.
Yeah. So I guess in that case, let's see. So in that case, it does really make more sense to, at least to me, to have it be the way I first said, where O can be, and this could be L or whatever. L can be 1, or it can be I.
Yeah.
O can be capital O, or it could be 0. Okay, so then just working with that, basically, I'll do, yeah, that definitely does make the recursion more complicated. But so in AdWord, let's retrace that. So now that char reps lookup is going to be that would be a list of lists if I built it out that way. So what I can do instead is do that lookup in each step, basically. So what I think I really need to do is I think that this should instead look like self.roots of 0 dot add next.
Another thing too is instead of roots, do you maybe just want like a root node?
Yeah, so I guess I could just do beginning basically.
Because I guess otherwise you're just chopping off the top node and making an array of the second node instead of there,
Yeah. So I'm not sure what a good convention would be there. Just like something like start, I suppose.
Whatever you want to call it, yeah.
Yeah. So equals try node. Um, and then, well, we can just do, that or whatever. Okay. And then, so basically, I guess we can do, then it can, yeah, all be one function. So add next would be, chrono.set next. So then for each character in the word, or basically we want to pass the word down with the start getting chopped off each time. So then in add next, we'll do, so we've got the current node, set next to, and then add next needs to have the next, jars. Node set next. So then this will be a list. Oh, I'm getting a call on my computer. That's not a good sign. Okay. So that'll be a list. So basically, we can do something like all next equals self.char reps of next jars. And then for next char in all next, chrono.set next, all next, and then and then self.add next. Or hold on. Oh man, it's been so long since I've coded up a tree of any sort that I'm getting confused at like where everything best goes, for to sort of like abstract away and make it very, very readable and easy. So okay. Yeah,
I guess that next node that you make, you want to recurse on that one.
Yeah. So yeah. Or so what I really need is for next char and all next, I need a I need to make a node for every next character in that representation. So new node equals try node next char. And then self.add next. I guess return self.add next. Or one sec. Sorry, it's getting. Okay. Man, really slowing down. Make the new try node, and then I'm doing self.add. Okay, let me just think about this for a second. Okay, so
yeah, you're almost done with the hard part.
Yeah. Okay. So first, just for some cleanup, you can just say self.root equals tree node nothing. And then, oh yeah.
Oh, I'm in insert mode.
Oh yeah.
Who uses that?
So really, I don't want that self.root 0. I want a single. I want a single function. So. So basically, what I want is to build out the branch coming off of that root node, as defined by that next character.
Mm-hmm.
So I want a bunch of returns. Ultimately, what I want is, yeah, a bunch of returns. So I'll basically return some node here. And I can just do that for an easier representation. So just to sketch out the shape of the function, I want to return some node, and then that node will be guaranteed that every path from that is built out. So really, what I want to say here, I think, is for this to be equals self.addNext of self.return. Although, it's not necessarily. And wait a minute. I'm still doing a lookup there, where I shouldn't be. So what I should say is self.root add next, I suppose, for each word. Man, now I'm just getting really confused about my sketch over it. So
Didn't you want to do basically something like self.addNext? I guess this dot not this self.root.
Mm-hmm.
You have your next characters, which is basically the word, but I don't know.
Yeah.
You need to like make that into a list or
Right.
whatever.
Right. All right.
That's it, right?
Yeah.
So.
Okay. So self.next root, and then a list of the words. So I've got all of the next characters there. So then.
Also, I don't know if you need to return anything here because you're not using the return value. So
because now that's just add next. Yeah.
Might make it easier.
Yeah. So then, in that case, I can do. I've got current node. I've got my next characters. So I need to fetch every representation of the head of next characters, and then I need to basically make a new next node, append it to cur node, and then recurse on that. So then new node equals try node of next char. Yep, that works. And then I need to add that to cur node. So cur node dot or add next. Oh, and so then so this is kind of running into that again, where I've built a tree node down there. So really, I can just do. Although that actually works pretty nicely. So really what I can do here, and I already built that out, is next char. I don't need the next node here because I already make it. I believe. Yeah. Okay. And I don't need to actually make a new node. I just need to do add next, and then okay. Here's part of the confusion. I've named both of these add next.
Mm-hmm.
So then I guess I can just do add char, and then self.add char of.
So you're also going to want to recurse on the new node? Okay, I guess you're just looking it up that way.
Oh yeah. Dot get next of next char.
So then I guess.
And then uh, word of one.
So you have get next as a function, not a dictionary.
Oh, right, yeah. Yeah, and then I'm just doing, I'm doing a return, yeah. Okay. So, then, yeah, it just steps through for every character in next, add that, word of one. So then I might come to an index error here, where I'm trying to get the first node of, well, so, what happens if I do, you know, so I'm assuming this is just going to be an empty, yeah. So I can really just do, next jars.
You don't need this list here, do you?
No, I don't.
All right.
Okay. And I can delete all those. Okay. So I guess I'll get errors if that doesn't work, and then assuming that that works, I believe that that should be good. So then I need to do so pre-compute. Yep. So add word, and that should just work. So then has bad word of name. So is it all right if I add an argument to this, or should I build out the tree right here? Like how am I passing this tree? Is there a preference of how I pass this tree to the has bad?
Not really. I think maybe what makes sense is this pre-compute could have like make some global tree, or you maybe just, even though maybe you could just compute this on every time we call a has bad word,
right?
Knowing that it could just be pre-computed in the future.
Right.
However you want to do it.
Okay. I guess we'll have some kind of global. So like down here, I'll build it out, since presumably we would want some instance, and then I don't know how you do it in writing industry code, but I know that what I would do is just pickle the object, use that pickle library. So then global tree containing bad words, or pre-compute global tree containing bad words, and then store it in a variable. So then, assuming that we've got this global tree, which I'll just call tree, then basically I need some kind of lookup now, where I do so where I go through every character in has bad word, or basically for start index, range, name.
Maybe before we do that, do you want to kind of tie up some loose ends here, like define this mapping, and then create the tree and give it the array of bad words, or
sure,
array of bad words, and then with that you can test your code, because we haven't tested any of this code.
Right, that's true. Yeah, it could just all break at the very end. Okay, yeah. So then let's get a so pre-compute bad words. So basically, what I want is so return bad word tree. So then let's do pre-compute, and then so tree equals pre-compute, and then I need bad words. We'll just give it hello, I guess, and then we'll give it this precise dictionary, in fact, and then maybe just account for a few more of the, like, or we'll yeah. Hmm. Because then we would also need I guess this is where, yeah, that intuition failed. We would need the exact same reverse there. So, man, yeah, I need a
Maybe
better map.
don't put it all on one line, I guess. So
Yeah,
yeah, if you do right, so you have H can be H, obviously. E
yeah,
can be E or 3. L
yeah,
can be L or 1, and O 0.
yeah. And then I guess if we really wanted, we could build out that mapping. I'm just getting concerned because clearly that would take an enormous amount of space because you would be storing things, several times basically. Um, where, like you said, you would also have to have an entry here, which would say, one goes to, yeah, L or whatever. Um, so that might not be the best mapping. Uh,
I think the approach that we have right now is fine given
that
the
works.
the
Okay.
data that we'd be working with and how
Yeah.
cheap memory
All right.
is today.
Yeah. All
But
right.
yeah,
So
good
that.
concern to have because depending on the data that you're using, you could very easily get like exponentially compounding
Right.
memory usage.
Right. So then I have no real way to print this tree. Um, and that would be potentially pretty difficult to come up with a way. So I'm just wondering what the best way to test this would be without building out like a function to tell whether a word is in that tree. Um, so I guess that will be the way that I test it. And then so I can do print. Maybe I'll have a function has word like hello. Um, and then another one with something similar, but yeah. So this is the concern I'm running into, where if I had something like that,
Mm-hmm.
I guess I can just make that entry as well.
Yeah.
Okay. So then, yeah. So then I need to write this has word. Then I guess, assuming it'll follow this. Yeah. Okay. And then, um, so I can do, let's see, um, so basically the statement will be if at each iteration of this kernode next chars, basically if kernode.get next, or so if next chars 0 is in that kernode.get next. But so that just returns a bunch of nodes. So I guess maybe I should do something here. So char.
So you could also maybe make your has word recursive as well, right?
Yeah. Oh yeah, yeah. So
So like if you know if the tree does not have the first character,
uh-huh.
you know, return false.
Right, right. Yeah. So um, basically, if if the very first character, which starts out root, is in that first node, um, uh, oh, whoops, I don't know what I'm doing with that. So if word zero uh, basically is in self.root. And then, so how do I test for that? So self.root is a tree node with 0. So then get next nodes, I guess I could say if it's in the keys of next node.
Do
Yes.
you want to, I guess,
Yeah,
start with
yeah,
the root node?
yeah. So then, um, so basically, you know, if it's in the node dot get next dot keys, then else return false. Well, so then also if I bottom out and the entire word has been found, or so, then yeah, I would return true. So basically,
Yeah, that's
if
another base case. Yeah.
return true. Um, um, else if it's in get next keys, then return self dot has word. Word starting at the first character, and then node dot get next of word 0. Oh yeah, I keep doing that. Yeah, I think I've been confused at whether I was thinking of get next as return as like a wrapper for the indexing, but I didn't wind up implementing it that way. So okay, get next of word 0. Okay, and I think that is that's about it for has word. So then I'll need to do both of these tree.root. And then I guess there will probably be a lot of errors, but let's test this out. Oh, right. So that's line 9. Oh, wait.
It says line 40.
40, I mean. Okay. Oh wow! I yikes! I just
didn't finish that thought. I see.
Yeah. Line 16.
Okay.
Oh, huh. I don't know why I had that call there. Okay. Sure, there are all sorts of just typos here. It's been such a long time to get here.
Yeah, we wrote a lot of code without testing it.
Yeah, yeah, that's true. Definitely should have been testing much more quickly or at each step. I meant to do next chars of 1, so. And then next chars. Oh wait, oh no, I've got an all next. So that actually should be next char. This should be next chars of starting at 1. So that's not great.
Okay, but it didn't blow up.
Yeah, it didn't blow up, so that's good. Okay, so Now I guess I just need to see basically what's going wrong. So as word. So then for huh. Okay. I suppose honestly here, without a very, complicated debugger showing me the states of things, it would likely be, oh, what happened there?
I
Oh,
should be able to do this, right? Or oh
yeah.
no, I want to
No,
do
it's,
tree dot
yeah.
root,
Try that get next. Treat that get next.
tree dot root like next, right?
Yeah.
Okay.
So yeah, yeah. Um, huh. Okay. Hmm. So what's going wrong there? Um, root docket. Um, so okay, I guess I should look at when I'm building it out. So with tree.precompute, in that precompute function, Edward tree equals tree of, and passing it character representations, and then for each word and bad word, this is very easy. Oh, well, so, huh. I did assume that this was going to be a list of bad words, which probably is not might not be the problem, but I should definitely see what that does. Okay, true. So, huh.
Okay, yeah. So,
So really the problem, I think, was that I was breaking up hello into H and E and L and L and O.
yeah. So
Okay.
this is looking good. So I will say that there is a. It's funny enough that the bug that you have here, at least one of the bugs that you have here, is the
Yeah.
same bug that I had when I wrote this problem initially.
Really?
Can you think of any ways that you could have let's not worry about the mapping. Given
Yeah.
given the mapping, is there maybe another list of bad words that would leaving hello in here that would make this false? Because in your
Yeah.
has word you wait until you get to the end of the tree to see if that's a bad word.
Right. Right. So if I just had like hell, for example.
Well, hell is not a bad hell is not a bad word by this definition.
Yeah, yeah,
if you,
that's what I mean. Yeah.
Yeah, so if you had a hello,
Right.
then it should be false, false, false.
Right.
Oh wait,
Oh.
not true.
Huh. That's strange. So then maybe that in itself is a problem. Um. Hmm.
So the idea
Oh.
is that we
Uh-huh.
oh wait actually maybe so the idea is that if you have the tree built out, maybe the tree stops whenever you get to, let me see, okay, add character, has word, so my thinking was that we would have the tree built out for all the variations of hell, and then hello, or hello, and then hello with the extra O's. And the way that we figure out if a word is bad is that we either get to the end of the tree or we run out of letters.
Yeah.
But if you look for hello and this is in there, then your tree is longer and you don't get to the end of the tree. So basically,
Right.
you either need to prune your tree such that the end of the word is in. So you just stop whenever you get to the end of any word, because I guess by this definition, if you have a substring, if you have this, then this is kind of redundant to have this second word here, because
Right.
this bad word has a bad word in it.
Yeah, yeah.
But also, this isn't fully. This doesn't cover all the cases here. What you wanted to do is look at all the substrings of that name and see if, or not look at all the substrings, but look at start at every.
Yeah, that's
like X hello.
yeah, yeah. Yeah, that was going to be my next step. Was in has bad word.
Okay.
I basically would for each index, I would do 3.has word.
Okay, cool. I'll give you that one then, because I guess I stopped you before you completely finished.
Oh yeah.
But yeah, this is cool. I think what I'll do for the viewers is I'll actually, I guess, have the solutions that we wrote out, and then also maybe like a, I'll post this. I'll post these solutions, and I guess it's time for feedback then.
Yeah.
I'll jump to the first one. I guess I want to make this fairly quick. Since we spent some decent amount of time on this problem.
Yeah.
I guess how do you think things went?
Honestly, not the best. I don't know if I was just not as much on it this time, which isn't really something that you can say during a technical interview.
Yeah, even though you kind of did say that, you're like, oh, I don't think this is my day.
Yeah.
It's not the best thing to say.
Yeah. I should definitely not say that in particular during an interview. But then, on the whole, I think I was thinking much more narrowly for whatever reason. It was tough to keep track of my entire approach so far to the problem, especially within that very large problem. And then get largest product. I think I might have had the opposite problem to last time, where I was a little overly concerned with the runtime, because I was thinking after I could just, especially after you writing that line, that I can just rely on the efficiency of Python's own algorithms, and I could just work with a sorted nums, check first and last, and however many I want to check.
Yeah. So I was as you were talking, I was kind of looking up some syntax. There's the nice like shorthand, which I can't think of what it is off the top of my head. If I want the first two values, is it like that?
Yeah.
Okay. And then high equals, I guess, nums. And these are the last two values? Or is it like -2 or?
It would be -2.
-2.
Or yeah, I think -2.
Or is it like this? Or
yeah. No, that would be ending at -2. It would be that way.
Okay. So basically, I think we could have started with a solution like this. 0. Well, you get the idea. Low 0, low 1,
right,
and then high 0. Nope. Times low 1. So yeah, kind of work with a sorted solution, and then maybe you could work on a solution that kind of builds up these little arrays.
Right. Right.
And go from there. I think you didn't do too well on the first problem. I think on the next problem you actually did fairly well with I think some kind of strategic missteps. And I guess we'll go over these problems with the rest of the feedback that I have now.
Yeah.
Right. So on the first problem, you asked some really good clarifying questions, really about all the clarifying questions that I could think of. Are there at least two elements? Are they all positive? They're not. Things like that.
Right.
You didn't ask about runtime constraints, but then you realize like, well, there's an order n solution. How can it get better than that? So that's fine. And you didn't consider like the negative times negative until
which is pretty big.
That was funny. And you used the prompt, which was nice.
Mhm.
and you verified, like like 5 is greater than none.
Right.
Kind of playing around with that. Yeah. As for that one, I think I think that one was okay. I wasn't really too impressed, but like you tackled the problem and asked the right questions.
Mhm.
And I think maybe I guess you felt a little rusty on that problem. Would you say that? Or
Yeah, yeah, definitely.
okay. As for the tree solution, I guess I'll paste that back here.
Uh-huh.
So the tree solution. So this was a pretty damn hard problem, and I wanted to see
Uh-huh.
how you do because there are definitely interviews where I think this is everything. There are definitely interviews where like the interviewer will give you something that is like almost impossible or impossible to finish in like the desired time frame. We didn't really
Mhm.
time cap this because we're already been doing this for a little while.
Yeah.
So sometimes they sometimes they kind of want to see like, well, how well do they handle something that's like really difficult? Do they get overwhelmed and give up, or do they kind of tackle it piece by piece?
Right.
And I think you're kind of given your experience and the difficulty of this problem. I think you tackled this really well, but I did give you some hints as
Yeah.
for kind of strategic missteps, and I want to see if you're aware of those before I kind of hand them to you. Like how if you did this problem again, apart from knowing the algorithm better, like how would you have done it
Mhm.
differently?
Um, I mean, for me, well, so if I was doing this like in a production setting, I would actually go back and look back at my old tree code, honestly, because I know that there are some abstractions here. Like I was even thinking that I was doing something with get next all the time, like you saw.
Mm-hmm.
That I was using that essentially as a wrapper for the dictionary indexing, rather than just returning the dictionary itself. Um, I think that, yeah, I mean, beyond that, I might just be still too caught up in this problem. I think that this is, I mean, I would have maybe chosen a slightly different setup for mapping, but I would have to think about that in itself for a
Mm-hmm.
while, I think,
Well,
before I
I'm
could.
thinking at a kind of a higher level than that. Maybe
Yeah.
I said this while we were doing the problem. So you wrote pretty much all of the algorithm before testing any of the code.
Yeah, that's definitely. I actually already noted that down in Notepad. I
Okay.
need to test much more granularly, because yeah, I wound up with essentially two full classes almost entirely filled out before I ran a single test.
Yep.
So
Yeah. Fortunately, the base algorithm was accurate.
uh,
Um, I yeah I think okay. So yeah, so the base algorithm is pretty accurate. Um, and you instantly jump to the tree representation, which I was really impressed with, because
right.
that's definitely the right way to do this.
Uh,
And another kind of feedback that I had was really related to not testing the code. You didn't define the character mapping, and you would have needed to do that if you wanted to test the code.
yeah,
So that's really just a side effect of that.
yeah.
So yeah, I think a question like this is probably a little harder than something you might get for an interview on site. Uh,
Uh-huh.
when I was asked
But you
this
said,
question,
is this the one that you said you actually got this question?
yeah, I got this question. I was given an hour to do it,
Uh-huh.
and that was with someone that they were looking for someone with like 5 to 10 years of experience,
Right.
and this was one of the on-site questions.
Uh-huh.
Um,
Yeah.
so it's tricky. I wanted to see how well you did, and I
Yeah.
was actually fairly impressed with this one. I was not so much impressed with the other question.
Yeah.
So
Yeah. The
it's
other definitely did do as well.
yeah. As for the algorithm, you kind of thought that thought that up fairly quickly. I guess it was realizing that in the code. There
Hmm.
were some small missteps which were easy to correct, but your pacing here was pretty good. So I think your dynamic programming practice might have really helped out here.
Right.
Is there anything else that you wanted to, I guess, hear more about, or anything else you wanted to talk about?
I'm sure I'll think of things. I'm sure I'll think of a million things after we hang up. I mean, yeah. So I guess what do you think? What do you think would be the best, like, say, debugging steps, short of getting hints from the interviewer, like I effectively did in this case? Um, how? I mean, what would you? I feel like the easiest thing for me, and honestly, how I debug a lot of my code when I don't have access to, the nice like VS Code debugger
Right.
or what have you, is print statements because I've always had either just, nothing or the Visual Studio or whatever environment I'm in, the really nice debuggers. But I feel like print statements sort of, if nothing else, have reputation of just that's not a very elegant way to debug.
Yeah, that's a good point. I guess that's kind of a rough edge with asking fairly complex problems over an editor like this.
Uh-huh.
Maybe something like this. Maybe a better format would have been, we let you screencast and it's on. You're using tools that you're familiar with. Admittedly, that's how I was asked the question.
Uh-huh.
So that definitely made it a little easier for me. I think actually I wrote this solution in JavaScript, and
Uh-huh.
I was using plain objects. So what I was able to do is use the form of console log that printed out a nice tree structure where it showed the character and then
Right.
the node beyond that, and so we had this actually a tree structure in the command line, and I didn't do so much kind of debugging
Uh-huh.
because it was either like syntax errors or the tree was just shaped wrong.
Yeah.
So yeah, I guess here uh, is a little tricky since I don't know if there's an easy way in Python to print like nested dictionaries. We also did
Uh-huh.
make this tree node, which is a wrapper on dictionary. So I think yeah, there might not have been an easy way to print that out. So
Right.
that's I guess definitely a rough edge with how we ask this question.
Uh-huh.
So
Yeah,
that's a
but
good point.
definitely, I mean, definitely good to keep in mind because I think, presumably these questions are just going to persist and they'll say whatever language you're most comfortable in, right? And
Hmm.
I'm definitely the most comfortable, and certainly for something as speedy as like an interview question, definitely most comfortable in Python. So I think that that might probably come up in actual interviews. So
Hmm.
it's definitely a good thing to keep in mind.
Yeah.
Yeah. Well, all right, and so yeah, I suppose that's about all I can think of off the top of my head. What? So if I'm faced with a question that I know is simple, like the first one, and for some reason I'm just running a blank, do you? I mean, that's kind of a big thing to ask. Just do you have any solutions for that? I mean, what do you think would be the best approach for something like that?
Um, well, I think you tried once or twice, kind of taking a step back and thinking about the problem again.
Yeah,
I think you were listening to some of the feedback that I gave, where like we had some
yeah,
copied code, um, and you were averse to doing that again. Um, yeah, I think for that problem specifically, it made sense to just grab the two smallest and then the two largest values, um,
yeah,
like I showed you kind of with the code that I sort of wrote out, sorting it and then grabbing the first two and then the last two,
yeah,
printing those out,
yeah.
printing the result of that, and then replacing the sort with something where you pluck those values out instead of doing a sort.
Right.
um, I think would have been like the optimal way to go. I think writing out kind of the more exhaustive solution where you're kind of writing a lot more code and then you clean it up later,
Uh-huh.
might be better than kind of just waiting and not having a solution. But
Yeah.
maybe you'll come up with a proper solution real soon. I
Mm.
think because your question is basically like, what do I do if I don't know what to do?
Yeah.
um,
Yeah.
and yeah, I think what you did was fine. Just kind of taking a breather. It's
Hmm.
definitely all right to take those
Yeah.
a few times during a problem, but
Right.
I guess everything in moderation. So
Yeah. definitely.
I guess my answer to that is just practice.
Yeah,
More.
yeah, which I definitely need to get a lot of in.
Yeah.
All right, well, thank you. I mean, that was definitely seeing the really large problem, and having to come up with that on the spot, I think will be very helpful.
Cool.
Um, yeah, and even just to see that I guess could get somewhere, even if I needed a lot of help with that, is it's definitely a bit of a confidence booster. So
Yeah,
yeah.
I think your algorithmic approach was pretty spot on. It just the writing the code, there were some rough edges, and you seem to kind of slow down towards the end
Yeah,
too.
yeah, definitely.
Um, so yeah, I don't know if I would anticipate spending that much time on a programming problem. That might an
Uh-huh.
hour is probably going to be the upper limit.
Right,
But
right.
yeah, I think I'll also post this in entirety so everyone can kind of get a fair representation, and I'll have
Right.
a little legend of this part starts here and this part starts here.
Yeah.
But you must be very hungry. I am too. So,
Definitely, yeah.
all right then. Yeah, you can send me your updated resume, and we can go over that offline, and then maybe talk about it online as well.
Great.
I guess we can do another session and maybe go over some more moderate dynamic programming problems,
Hmm.
because I think the answer to I guess getting the most value out of our time together is really just to grind through these, and
Yeah, a lot of practice. Yeah.
yeah.
All right.
But
Great.
yeah, I
And
like what I saw again today. So
awesome. All right.
great
Thank you
then.
again.
Yeah, thanks, Luke.
Bye.
Bye. All right, guys. Here's the test case that I was trying to show you. So if you have hello as a bad word, and then hello with ones as a word that you're testing, you get true. That is a bad word. But then if you add one more, we just that happens. So what you want to do is, I guess, on every node that is a leaf, first of all we'll say self dot is end equals false, and then add next. We'll just say on the end of any word. So add word, self add character, word. Okay. So if next character is, then we'll do else current node is end equals true. And then on has word, we'll do if not word or node dot is end, return true. And there you go. That's the fix that Luke and I needed on the problem, and there it is. All right, thanks guys.